Hello guys, welcome to Tough Math, a YouTube channel that features solutions to some math competition problems given in the past several years locally and internationally. So here's our first problem for today. What is the coefficient of x to the fifth in the polynomial expansion of the quantity 2x squared minus 3x plus 8 raised to the power 4? Okay. Here we consider the terms for taken 1 and then 3 and then 0. The 1 is for the 2x squared, so 2x squared you raise it to the power 1, and then 3 is for the coefficient 3x, and then the 0 is for the 8. So when you multiply these coefficients, it will give you x to the fifth. And then the other term is 4 taken 2 and then 1 and then 1, where 2 is for 2x squared, because 2x squared becomes 4x to the fourth, and then the 1 is for negative 3x. Okay, so this is 3x to the 1, and then the other one is for 8. By the way, this one is 0. And so you have this is equal to 4 times 2x squared times negative 27x cubed, and then times 1, because a to the 0 is 1, plus 4 taken 2 is 12 times 4x to the fourth times negative 3x times 8, and this gives us negative 216 x to the fifth. Then we also have negative 1152 x to the fifth. So in total you get negative 1368 x to the fifth. Therefore, the desired coefficient is negative 1368. Okay, so that's the answer to the first problem. And then the second problem, find the remainder when the number m, which has 201 digits actually, no? It starts with 99 23s followed by 453. So first we count the number of digits of this number m. So it's actually, since there are 99 23, so we have 99 times 2, because 23 is a 2-digit number, And then we add the 3 digits coming from 453. So this is 198 plus 3. So you have 201. 201 digits. And then note also that when you take 3 23s, okay, this one, it's just actually 23 times 10 to the 4th plus 10 squared plus 1, which is equal to 23 times 10101, which is equal to 23. It's very obvious that the number 10101 is divisible by 3. So we have the factor 3, and when we do it, we have 3,367, and then we have 323. 3367 is divisible by 7, so we have 481. Okay, let's put the 7 in front. So we have 7 times 3 times 23 times 481. Okay, we put the 7 in front because our problem is to determine the remainder when the number m is divided by 7. Moreover, 453 when you divide it by 7 is actually 7 times 64 plus 5. Now, thus m is actually equal to 23 times 10 to the 195. Yes, 195. And then minus 6, that's 10 to the 189. And then minus 6, that's 10 to the 183. And so on. We have 10 to the 9, and then 10 to the 3 times or plus 453. Okay, and therefore this is equal to, since the 23 is divisible by 7, in fact it is equal to 7 times 3 times 23 times 481 times 10 to the 195 plus 10 to the 189 plus 10 to the 183 plus and so on plus 10 to the 9 plus 10 cube plus 453 is 7 times 64 plus 5. Okay, so therefore we can write this number m as 7 times k plus 5. where for some k. Actually, k can be uh, taken from the previous expression or from the previous equation, but I'm not doing that anymore. So anyway, the important point is that we have shown that m is equal to 7k plus 5. Therefore, when m is divided by 7, the remainder is 5. Okay. And for the third problem, we have a positive integer n leaves the remainder 4 when divided by 5, 2 when divided by 8, and 1 when divided by 11. Find the smallest 4-digit number. Let's use P na lang. Okay. Let's use P. And then for this one, okay, M. And the largest 4-digit M satisfying these conditions. Okay. So we have for some integers P, Q, and R, we have n is equal to 5p plus 2. 5p plus 4, because the remainder is 4. And this same number n is equal to 8q plus 2, because the remainder is 2. And the same number n is equal to 11r plus 1. Okay. Now, when you add 6, n plus 6 is equal to 5 times p plus 2. Plus 2 because when you add 6, the 4 becomes 10, and 10 is 5 times 2. And then, when you add 6, the 2 becomes 8. And so therefore, this one here, this expression here becomes 8 times q plus 1. Okay, and this is equal to the LCM of 5 and 8. Yes, 5 and 8 times k. We introduce this factor k in the expression for plus and 6 to take into account that there is the third number, third expression for n, which is 11r plus 1, which we have not included in the LCM, in the least common multiple. So we still don't know what k is, but so for the moment, let's just let it be a positive integer n. Okay. Now, When k equals 1, then we, by the way, this is 40k. So when k equals 1, then you have n plus 6 equals 40, which means that n is equal to 34, which can be written as 11 times 3 plus 1. Okay? Now, thus, n, which is equal to 40k minus 6, okay, is equal to 11r plus 1. So now we are including the last expression for n, which is 11r plus 1. We have incorporated it into this new expression, and from here we get, when you subtract 34 from both sides, you get 40 minus 40k minus 40. So 40k minus 40 equals 11r. When you subtract 34, then you have minus 33, from which we obtain 40 times k minus 1 equals 11 times r minus 1, which gives us the ratio k minus 1, ratio and proportion actually, 11 equals r minus 1 over 40. And if we represent these two ratios as just t, the parameter t, then we have k is equal to 11t plus 1. And for r is equal to 40t plus 1. Plus, wait a minute. This is not 1 here, sorry. This one is 3. This one is 3. So this one here is 3. So this one here is 3. Okay, 40t plus 3. Therefore, n is equal to 40k minus 6. So you have n is equal to 40k minus 6, but k is 11t plus 1, so you have 40 times 11t plus 1 minus 6, so that gives you 440t, and then 40 minus 6 is 34, so plus 34. Actually, you get the same expression when you, instead of using k, we use r. So we have, or n is equal to, where is that? (11r plus 1). Okay, n is equal to 11r plus 1 from here, from this. N is equal to 11r plus 1, but r is 40t, so you have 11 times 40t plus 3, and then plus 1. So you get the same expression for n in terms of t. Okay, so we have this. And to get p, when we determine p and m by trial and error. Okay, so when t equals 3, we get n is, this is now p. The smallest, so we have 440 times 3 plus 34. This gives us 1,354. Okay, and this is the smallest 4-digit number satisfying the given conditions. And when t equals, again, this is done by trial and error. We try specific values of t, and it happens that when t equals 22, we have m, the largest 4-digit number, which is 440 times 22 plus 34. Okay, and this gives us 9,714. This is the largest because when you increase t to 23, it will now be more than 10,000, which is a 5-digit number. So this is now our result, and this is the largest 4-digit number satisfying the given conditions. Okay, so I think we have done our main purpose in this video, which is to show the solution and the answer to the questions. And now let's look at this challenge, as I have been doing in the past several videos already. I always leave with a challenge to the viewers, or for the viewers. How many odd numbers are there between 10,000 and 60,000 in which no digit is repeated? So challenge yourself to solve this problem first. And after doing that, if you want to see the solution and the answer to this problem, go to the next video. Watch the next video, because the solution will be there. And again, and also, I would like you to think about this. The following is an opinion about mathematics, and this is according to Bertrand Russell. He said, mathematics rightly viewed possesses not only truth, but also supreme beauty. That's it for today. I hope you enjoyed our discussion. You learned something from it. Goodbye for now, and may God bless you.